Let me welcome you to this webinar, how to add NFC to your products and when using the NFC Nutshell Kit. So the agenda for today, let me just move out here. The agenda is drivers and reasons for adding NFC, some insights, what's the issues with NFC and prototyping, some approaches, and then a deeper dive into the Nutshell Kit, what it is for, what it does, and how to use it. So some drivers and reasons to add NFC, there are some questions to be answered, like what are you looking for? Why NFC? Do you want to identify parts, for example? Do you want to protect your brand? Do you want to make sure you're using original supplies? Do you want to add safety? Do you want to do automation? Do you want to do parameterization of a machine, a device? Do you want to add security, enhance consumer experience, and all the likes? So if you want to add security, what is your needs? Do you need to authenticate? Is a basic password protection okay? By checking a signature, for example, do you want to do integrity checking? Do you need encryption if you're communicating between NFC tags and reading devices? All these kind of questions needs to be answered. What is your operating distance? How far do you need to communicate? You have a part and a machine, how far are they apart? Do they rotate? All these kind of things. And a very important one is, how constrained are you in space? How big is the antenna area? And that impacts directly, so size, antenna size, and operating range are in direct relation, together with some output power, etc. So prototyping, there are two different kinds of customers. Ones they already know, they want to add NFC and they know about the benefits, what it brings to the customers, and others who don't really yet understand NFC, but want to give it a try. So, and even then you can distinct some of the questions. I want to do it, but I have limited experience. So therefore also limited resources. I don't know for my application which chips to use and where to get them in an appropriate form factor. Do I also want to add mobile applications to that? How does it look like if I add NFC into my device? How quickly can I create a prototype? And questions like that. And the others who don't understand NFC yet often have the feeling it's very complex. And they're not sure if it will add value to their product or it will enhance the customer or user experience. Cost involved, also unclear. And still they want to see a prototype, and then all the certification, what cost is incurred, what effort is there to be taken, some other questions. Then when it comes to prototyping, NXP offers a lot of demo boards of all its products in several shapes and sizes. If you think about evaluation boards of reader ICs, they are rather versatile. You can do a lot of things with them, but the size of the boards, including the antenna, is an issue if you want to integrate that and showcase or demonstrate a use case in a given product or scenario. So the tag size is another thing, so the counterpart of the demo boards. Small tags, which one, security, yes, no, how do I get them, how small can they be? And then still antenna needs to match the size of small tags. So how do I put them, where do I put them, where do I fit the antenna, is issues related to many of our demo boards. On the software side, do I need to write everything from scratch? What software is available? How can I use it? Do I need to write it on my own? And how can I quickly use available software to create some demo use cases? If you compare a bit custom built boards versus some prototyping, the question is, how flexible can I be? If I need to try out different NFC front ends, for example, I need to build up the boards. If I try to have different MCUs controlling the NFC front ends, I might be redoing my boards. Antenna, the same thing. Software, of course, yes, should run on both. Sometimes you want to use existing tools like the NFC Cockpit from NXP to try out different settings, but on the custom built board, USB interface is not available, so you cannot use that kind of tool set. PCBs, not necessarily small, but built for the purpose in integrating. If you need to change that, you need to build up a new board. Application software, can I run it out of the box? Do I have all the interfaces available? Sometimes not. Hardware exchange, I need to rebuild, or I flexibly combine some components available. And that is exactly the idea when it came to building a kit which has small sized components which can be flexibly put together. So we called it, because it fits in a nutshell, we called it the Nutshell Kit, or the kit was designed in a way to exactly bridge the gap between existing demo boards, very versatile, serving the purpose, highest performance. So the idea was we need small components which you can put together in order to retrofit it easily into existing products, in order to demonstrate what NFC can do for existing products, or you put it into prototypes which are in prototyping state, 3D printed, and you need small enough antennas and components to put on top of your existing electronic, for example. So it was really, how can I have something small enough and flexible to integrate it into products. So this was then developed outside NXP by GMMC, an approved engineering consultant of NXP for NFC. And now let's see what are the benefits of the Nutshell Kit. So we call it nano-sized modules because they're really small for space constrained environments, because sometimes you want to put it in a toothbrush, very space constrained, everything very tiny. How could you put that in, or at least put antennas and parts of an NFC solution in there to show the use case? It is flexible for configuring different stuff, interfaces, MCUs, and different front ends to that. It supports, so there are NFC front ends of the most popular NXP reader writer ICs like 663 plus family, so 630, 631, 610, PM5180, PM7150, and for the Apple MFI licensees, also 7150X is potentially possible, and 7462 family. And most importantly, it can be used with the existing tools and from NXP, like NXP Cockpit, RFID Discover, the MCUxpresso for building your projects, and the software debug interface adapter, the LPC Link 2. Which components are in there? And it is 3 categories, and even on the PCBs in the right upper corner, you can see that there is a color coding. The PCBs in red are all related to NFC. The PCBs in blue are all related to MCUs. White PCBs, they appear on this a little bit yellowish, but they're white. They are interface boards. And there is one green one, which is an adapter for the Link 2. And then you connect it to a host system. Here you see, as an example, two different adapters, one with a pin out and one with a USB and a reset button. And from the NFC side to the antenna, there is a twisted pair cable where all the front ends can be easily attached to small antennas contained in the kit. What you can see here is 3 different types of white PCBs. So debug adapter, the USB adapter with a reset button, and one converter module which does USB virtual COM port to either I2C, SPI, or UART. So you can configure that with a software which has been built around that. There is currently 2 different LPCs, LPC 7069, that's the rather large one here. Why is that in there? Because that is contained also on most of the demo boards, and the software is available like NFC Cockpit and RFID Discover. Pagoda software is running on that. And another board, you see the smaller version, also a commonly used one with some interface options. You can use the other board, doesn't contain any software yet, but you could use that with interface option like SPI and some GPIOs to put modules like BLE or Wi-Fi or whatsoever on there. And then you have different front ends, like already said, from 663 family up to 7462, 7360, depends on what is there, and 7150 with the NCI stack. And it comes with 4 different antennas, from 2 by 10 millimeter, 20 by 20, 40 by 40, and around ID1 sized cards, so credit card sized. And they are to be connected to the NFC front ends with a simple twisted cable. All the NFC modules you can see here. On the left-hand side, you see the interface. It contains USB, power, and all the interfaces which you can think of like SPI, I2C, and UART, and 2 auxiliaries. So in total 14 connections which go from board to board to board. So they're routed through from the host interface to the NFC front end. And every of these mini boards contains a 3-volt LDO and XTEL, and the only restriction is from a microcontroller to NFC, the connection is always SPI. Additionally, the kit contains a small collection of small tags, some jumper wires for the debug adapter, some spare flex cables to connect the modules to each other, an antenna expansion cable as mentioned, USB extender, and the mini screwdriver to help you open and close these little FCP connectors for the flat cables which interconnects all the modules. In addition, there is one adapter which is designed to be fully compatible to the LPC link. You see how it is connected here. And the 2 MCU boards, they have a 3-pin connector, SWIO, clock and ground. So you need to power up the boards, but then you can use the LPC link to debug, download, and test out applications. Again, front end, the ones contained right now is 663 and 5180, and available is 7150. Even the good old 512 we did done is available upon request, but the latest edition 7462 family is also compatible with the NFC Nutshell Kit. The tools as mentioned, NFC Cockpit firmware needs to be loaded on the LPC 1769. RFID Discover is preloaded on the MCU, and it is also compatible with the NFC reader library. More information you'll find on the links above the screenshots here. So how to use it? Modes of operation of the protocol converter. There is a software which allows to program the operating mode, and you see it is 6 different ones. So the standard ones would be USB virtual COM port. You convert it to either UART, SPI, or I2C. Then there is one mode which allows, so there is some GPIOs on that protocol converter, and one mode allows to hold the programming lines down. And that is for downloading via FlashMagic, for example. Then you have a direct execution. What does that mean? No NFC, PC to the front end direct connection, which allows you to execute existing examples of the reader library. And if they're not too timing critical via the serial Windows driver, you can execute them directly via the converter on the board. So that mode is explicitly also in there. All the control GPIOs will be set. And then the very bottom, we come to that later, you can directly control via the virtual COM port to I2C converter, handling the enable pin. There is a special mode for the 17150. So just need those 2 modules in order to operate it. Here a little bit in explanation. So what is the basic setups? You take the desired hardware and configure it. So you say, okay, I need a converter, I need an MCU, yes or no, and I want to use this or that NFC front end, and then you interconnect them as shown with the flatband cable as shown in the left down corner. Then you configure, if you're using the converter, you configure it. If you use the USB, of course, you don't have to do that. But if you use the converter module, you configure the desired mode. Then it goes to development. You use the example like shown here, basic discovery loop, which allows you to detect various technologies and handspec the UIDs of tags, for example. Then you build your project using MCUxpresso, and then you flash it or put it on the MCU in different ways, either with FlashMagic or with the LPC link adapter, or in a way which we do later. So preparing hardware means use all the different kind of components you want to test, including, excluding MCU, direct connection. What you for sure need is any interface to the host, any NFC, and one antenna you pick. So again, the configuration of the USB converter in different modes as explained. You have a RGB LED, which has different colors depending on the programmed mode. When you start the configurator, it reads out and it then indicates the mode by having a red border around it. The reader library, there's plenty of examples existing for the reader library. Sorry, I deleted accidentally the examples in here. We'll add that back before we send out the slides. Sorry for that. So basic discovery, advanced discovery loops, and a lot of other NFC related standard examples are in here. And is compatible to that. So then you build using one of the examples. You import the project, you're building it up in MCUxpresso. You create either a hex or a binary file, depending on the method, how you put that on the MCU, and what kind of format is required. FlashMagic requires hex files. If you do that, I hope you're familiar with that kind of tool. So you could use FlashMagic. You see 1769 is selected. The COM board appears in the device manager. If you're not totally sure, you have a look there. Then you configure that. put the hex file in there, press start. The appearance of FlashMagic, this is the older version. The very new version looks more modern, but it is the same functionality supported. So flashing firmware on NXP MCUs. If you use the 11U68, you can do that same thing, or you put the USB converter at the USB plug module, press the button, power it up, release the button, and then you go, then a folder appears which is called CPR disabled, and it shows a file contained which is called firmware.bin. You delete that, drag and drop it, and you're done. And then reboot it and execute the firmware. That is also a way when it is supported on the MCUs that you do that via mass storage device. So several ways how you do put firmware on your MCUs. Drop any firmware file, it will be renamed. Next time it appears, you boot it, it will be renamed to firmware.bin. So a little bit different is it on the 7150. You see here a setup with a MIFI file, 40 by 40 antenna, and the converter module in the mode programmed directly to communicate with the 7150 via I2C. So that is the last mode we talked about that. You see that a little bit zoomed out here. And there is the example modified to that supports that converter module. So you can do peer-to-peer, you can read basic tags, it will give you a possibility to do some basic testing with the 7150 and the converter and the PC software. You see some use cases which we did for demonstrators, how you use those little tiny modules. Here you see a wired antenna, not one of the Nutshell kits. You see a matching circuit in the left down corner, and you see in that case a 7150 to test NFC in a given product. And we use the same thing. Some of you might have seen that for our tool identification demo. We used Nutshell Kit components and did put it in that little drill in there. So in summary, very small, very tiny modules, flexible to configure and to adapt to different conditions, environments, product setups. Very modular, you can use different interfaces. So with the debug extender, for example, and the jumper cables, you can wire it to existing electronics as well. So you don't have to use a converter or the USB, because the host could be embedded electronics where you just connect to an interface. Most popular NFC reader ICs and hence tag ICs are supported. It is compatible with the NXP development tools. Future new reader ICs will be supported and made part or available for use with the Nutshell Kit. And if you're interested in downloading documentation, how to use the different modules contained from interface, MCU, and NFC, you can download the documentation from GMMC's website. Many thanks for your attention and happy to receive your questions.
The first question is, which PC software can be used for PC NFC direct execution? Like you explain in the cases on lines 2 and 6.
Visual, I think it's the Visual Studio projects, which you can directly execute, and it's executed via the Win serial. There is a mode where this is possible. Details, I'll find out.
Okay. And one more, the important thing, how can one get a Nutshell Kit? From where they can get it?
It is on the GMMC website. There is currently a German distributor, and they're working on getting a US-based distributor as well, that it's easier. Other than that, contact GMMC and you can also get directly from them.
Okay. And the next one, what is the fastest way to add a serial communication into an embedded system and communicate freely with a mobile phone app?
In an embedded system, so well, you need to have a free either UART or other serial protocol like I2C, also serial, but 2 wires. And then depending on the NFC front ends you choose, you have either all 3 options. You have SPI communication to an embedded system, UART, or I2C. 7150 only offers I2C, others have UART and SPI. You choose via pin settings on the NFC front ends what is your host communication protocol. So, and the rest is implementing the serial protocol in the embedded MCU, but that should be rather simple. Question is which interfaces you have available on your embedded MCU.
Okay. And what is the RFID frequency used for this? For
NFC, that is HF, and it's 13.56 megahertz.
Okay. And is it possible to detect more than one tag in the same field with one antenna?
Yes. The method behind is called anti-collision, and if the firmware supports anti-collision, then you can detect more than one tag, because this is needed to detect if there is one or more tag. So they all start, the reader always requests the serial numbers, and bit by bit, the tags are starting to send them at the same time. And then if there is a collision, one sends a 0, one sends a 1, you can detect there is a collision. And then this anti-collision loops methodology, you get all the serial numbers which can be detected in the field. If there is too many tags, the detuning of the system will limit the tags, the number of tags you can detect.
Okay. And is this software of Nutshell Kit more like a plug and play? Which means if someone wants to run a prototype with Nutshell Kit in few hours, like.
Well, if he's familiar with the MCUxpresso, this is all based on the standard software and tools which we are using in NXP with our evaluation boards available. So yes, you can just take the example, compile it, run it, put it on the MCU or in direct mode, and execute it. Should be rather quick. The software running on that is the same. The form factors are totally different, and the flexibility in combining different interfaces and MCUs and front ends.